This is a practice problem for lesson 8.2, single replacement and double replacement reactions. So the question is, how do I predict the products of single and double replacement reactions? And the first example is single replacement. And to perform a single replacement reaction, you need to look at the activity series of common metals. In order for this reaction to occur, the element that's by itself, in this case chlorine, must be higher on the activity series than the one it's trying to replace, in this case bromine. And looking at the halogen activity series, chlorine is indeed higher than bromine, so this reaction can occur. So what's going to happen is the anion, chlorine and bromine, are going to switch places, making this Br2, because bromine is a diatomic, L, it's also a liquid, plus KCl. And this, because it is an ionic compound, is going to be solid. And I know that this has no subscripts because potassium has a charge of 1, balancing it out. And so now, what you do is, to balance the equation, you look at the subscripts of each of the elements on the left-hand side, and you write that over here. Do the same for the left. Now you see which ones are different, and I can see that both chlorine and bromine are different on either side, so I'm going to start off with chlorine. And I'm going to put a 2 here to make this 2, which also changes this potassium to 2 as well. And now I'm going to multiply this compound by 2, which makes both potassium and bromine 2. So now the equation is balanced. Now on to double replacement reactions, where the cations, in this case silver and potassium, are going to exchange places to form 2 new compounds. So, in order for this reaction to occur, at least one of the products must not be soluble. So first what I'm going to do is I'm going to look at the charges of all of these compounds, both monatomic and polyatomic. So silver has a +1 charge, nitrate has a -1 charge, potassium has a +1, and phosphate has a -3. So now I'm going to exchange silver in the place of potassium to make KNO3 plus Ag3 PO4, replacement there. Okay, and this is now Ag3 because PO4 has a charge of -3 and silver only has a charge of 1. Now I have to go to the solubility chart, and I have to make sure that both of these are not aqueous. So first I go to potassium, and I look at nitrate, and go all the way down to here, and I find that it is soluble, which means it is aqueous. So just write AQ here. Next I go to silver, phosphate, so phosphate, silver, and I find that it is insoluble, meaning that it's solid. So this reaction can indeed occur. Now it's time to balance, and I'll look at the number of each element on either side of the equation. So 1 silver, 1 nitrogen, 3 oxygens, 3 potassiums, or sorry, that oxygen is wrong, 1 phosphate, and then actually 7 oxygens. Now looking at the right hand side, there are 3 silvers, 1 nitrogen, 1 potassium, 1 phosphorus, and 7 oxygens. So the only thing here that is not balanced is the silver and the potassium. So I'm going on the left hand side first, and we're going to multiply this by 3. We're just going to make silver 3. It's also going to change nitrogen to 3. Oxygen is going to be altered as well, now forming 10. And now what I'm going to do is we're going to multiply this compound over here by 3, which changes potassium to 3, nitrogen also to 3, and oxygen to 10. So now this equation is totally balanced.